Okay, we're going to talk about lesson 5.5 where it's introducing the law of sines. And this is where we're going to actually apply the law of sines to solve some problems. And we're going to do a little bit of review from geometry. So the first thing I want to let you know is if you recall from geometry that a triangle has 6 parts, 3 sides and 3 angles, and that the size and shape of a triangle is determined by fixing only 3 of those parts. And in geometry, you remembered angle, angle, side, angle, side, angle, side, angle, side, 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 side. Now, angle, angle, angle determines similarity only. Side, side, angle doesn't even determine similarity. So, once you understand that triangles are congruent, you can find the remaining 3 parts using the law of sines and the law of cosines, which we will get the next day. All right, in the law of sines, this is the identity or the law that you have to remember. So the sine of A over A is equal to the sine of B over little b equals the sine of C over little c. A, B, and C are angles. So for example, here's the proof that we're going to go through. Here's my triangle. I have my angles A, B, and C, and I have the little a, little b, and little c opposite. And then the height is the shortest distance from point C down to AB. And when I do that, I can look at my right triangle, since SOHCAHTOA only works with right triangles, and I could say the sine of A is going to be h over b and solve for A. Now, I have this triangle here, because I could have an acute, or I can have one that's angle B is obtuse, which is greater than 90. And I actually know that I drop a perpendicular from C down there, that's h, and sine of B is going to be h over A, and I solve for h, which is A sine B. And since the h's are equal, I can put B sine A equals A sine B, and then I can actually solve, which I did not do yet. So if I do this, I've got sine of B over B. That is the proof of the law of sines. You don't need to know how to prove it, you just need to know how to use it. So let's look at this one. We have example 1, solving a triangle given 2 angles and a side. You always have to ask yourself if you have an angle and a side opposite. If that's the case, then you can use the law of sines. So I've drawn my triangle. Angle A is 36, angle B is 48, the opposite of A is 8, and the opposite of B is little b, and the opposite of big C is little c. Based on this information, I can now use the law of sines. The sine of 36 over 8 equals the sine of 48 over b. Cross multiply and solve for b. I'm going to do the same thing, but I need to know what angle C is. Remember in geometry, the sum of the angles of a triangle equal 180. So if I have the other 2 angles, I can find angle C, which is 96 degrees. Now I can set up the law of sines, and the reason I picked A is because those were given to me in case I made a mistake with B. Sine of 36 over 8 equals the sine of 96 over C. Cross multiply, solve for C, I get this. You need to check. The smallest angle should have the smallest side. Well, back over here, the smallest angle is 36, and 8 is definitely the smallest side. The next one is 48. B is definitely the middle number. And then the largest angle has the largest side. All right, now the ambiguous case is when you have a side-side angle, and it's going to depend on where the angle is. If the angle is included between the 2 sides, you have side angle side, and you can use the law of sines or the law of cosines later on for that. But if the angle is opposite one of the sides, then you are either going to have 1, 2, or no triangle. For example, I drew this one here, and it says A is obtuse, which means it's bigger than 90. If I'm looking at this one, to be able to make a triangle with point C, I've got to be able to connect here. Now, the shortest distance between 2 points is going to be dropping to a perpendicular, not between 2 points, between this point and this line. So what we're saying here is that the shortest distance is going to be this height, and that this side here better be bigger than h, and it probably is going to be bigger than AB, otherwise you can't make a triangle. Now if A is acute, I could actually drop a perpendicular and have this as my point C, or I could have where it is A is still acute, but my perpendicular is outside of the triangle, and now I have an ambiguous case. I'm either going to have something like this or possibly something like this. And we have to determine which one it is. That's why it's ambiguous. So let's look at this one. Solving a triangle given two sides and an angle. We have triangle ABC. We have A equals 7, B equals 6, and angle A is 26.3. I always draw my A here. I can see it better. So there's my angle. Opposite is 7. I have B equals 6. I don't know what little c is, and I also don't know what this angle is. But I can find the angle because I have an angle and a side opposite, so I use the law of sines. The sine of 26.3 over 7 equals the sine of B over 6. Cross multiply. Get B by itself. Now it is an angle. To find an angle, I always do an inverse sine of whatever this is. When I punch this into the calculator in degree mode, I get this for my angle. So now I have angle B. To find angle C, it's 180 minus A and B, so I get C to be 131.4. Based on that, I can then use the law of sines, set up sine A over A equals sine C over C, cross multiply, solve for C, and I get 11.9. A good check, the smallest angle should have the smallest side. So if I look, smallest angle does have the smallest side, the next angle has the next side, and the largest angle has the largest side. All right, for handling the ambiguous case, we have triangle ABC. We have A equals 6, B equals 7, angle A equals 30. So I draw my triangle. Notice I put A here. Opposite of that is 6. B, opposite of that is 7, and I don't know what these two are. Now that is one particular case. Because A is less than 7, that could be the case. The other one could look like this. And I don't know which one it is. That's why it's called ambiguous. So we have to solve for both because they didn't give us enough information. Now we should always check to see if my height is the shortest distance. So I take the sine of 30, which is opposite over hypotenuse, and I get h is 3.5, which is definitely smaller. It's the shortest distance, so I can actually make a triangle. So using this picture here, I'm going to try and find B. So I said sine of 30 over 6 is the sine of B over 7. Cross multiply, get sine of B by itself. If I want to find B, I always have to take the inverse sine, punch this into the calculator in degree mode, and I get this for my angle. To know what C is, now your calculator is always going to give you the acute one, but you're going to have to be able to find the fact that sine can be in two quadrants, and so we have to find the other quadrant. Now here we go. C is 180 minus 35.7 minus 30, so in this case, C happens to be 114.3, which is not quite there. I think it's bigger than 90. And now I can set up the law of sines, cross multiply, and solve for C, and there is my side. Now I've got to look at it. The smallest angle has the smallest side, 30 goes with 6, and then the next size angle, 35.7, goes with 7, and then the largest angle has the largest side. So that's one possibility, but I have to also check this possibility. So remember, your calculator is only going to give you one quadrant. So the other place that sine is positive is in the second quadrant. So I take 180 minus 35.7 and I get 144.3. If that's the case, then my angle C is going to be even smaller. All right? So now what I have to do is find the side. All right, let's see. Let's take sine of 30 over 6 is the sine of 5.7 over C, and I cross multiply and solve for C. Smallest angle does have the smallest side. Okay? All right. This is to be ignored. Okay? That is the ambiguous case. When you have an ambiguous case, you have to solve for both of them.